Hello everyone, welcome back to another processing video. Today I'm going to be working on something a little bit different. I'm not going to be working on a portfolio task for this week. Instead I'm going to walk through some core object-oriented programming concepts and then hopefully have a go at making this Atari game you can see in front of you. I know object-oriented programming can be quite difficult to get started with, so I'm going to go through some of the core concepts in some more detail than I usually would. So, before I get into any program, I'd like to talk about classes and objects. I like to think of a class as like a blueprint for the things around us. Before I go any further, I think it's important to know the difference between a class and an object. If we think of a class as like a blueprint, then we can think of an object as the physical representation of that blueprint. We can reuse our class blueprint to make as many objects as we want, all with their own slight variations. In computer science terms, we would say that an object is an instance of a class. So, if we think of our class as a blueprint and processing is our builder, what does processing need to know to make our objects? Classes are made of two things, methods and attributes. These seem like quite scary words, but really they're just saying what our class is and what our class can do. Attributes can be represented as variables inside our class that store data about the object. There are loads of examples you can find for classes that represent people, cars or chairs, but I'm going to start with something very simple. I'm going to imagine a 2D world and I want to just draw a ball that can bounce up and down. There's only two things that I need to know about my ball. I want to know the Y position of the ball and I want to know the size of the ball. We can store these two things as attributes in our class. The next thing we need to know is what our ball can do. For this we need to add some methods to our class template. Simply put, methods are functions that can alter the state of our class. In our simple ball example, we might have a method that allows us to check if the ball is on the ground, and then if it is, it should bounce back up again. I think it's easier to demonstrate this in code as we're already familiar with functions in drawing things in processing. Okay, so I'm here now in my processing window, and I think it's time to get started on actually writing some code. So the first thing I need to do is I need to define a new class. So I could do that at the bottom of our program here, similar to how I would make a new function. But processing has this nice tool where you can come up and create a new tab. So I think we're going to use that for today. So I'm going to be defining a ball class. So I'm going to make a new tab and call it ball. Classes typically have a capital letter at the beginning of them as a naming convention, and I think processing actually requires it. So the syntax for starting off a class is really basic. All we need to do is write class and then the name of our class. So now we have a new ball class. Like we talked about before, the first thing we need to get started with is adding some methods and attributes to our class. So I'm going to start off with the attributes and add in a couple of variables that I think you might need to define our ball. So I've added in a couple of attributes that I think that we might need to define our ball. Seeing as we're on a processing plane with an x and a y, I've added in an x and a y coordinate. It's a little bit more advanced than the example I was giving earlier, but I think it's easy to understand. So the next thing we need to do is add a constructor to our class. Now this is something we haven't talked about before, but basically a constructor is what allows processing to turn our class template into the objects that we can draw on screen. When I start out by making the class, this gets called automatically, and it'll run whatever's inside. Just like a function, it can take some parameters, so you can pass things into our class to kind of define what you want it to be like, and then it'll run some code. You can even call a couple of methods from in here if you really want, and then after that it'll return the class as an object, and then we can manipulate the objects later in our program. So we'll do this first. The first thing that I want to add is I want to be able to specify the start x and the start y. I'm actually going to call these start x and start y, just so it's really clear what we're doing. And then I want to set our class attributes to be equal to what we pass into the function. So we're going to do So we're coming up with something new here. I've got a this dot in front of our variable, and what this does is it just tells processing to reference the current object. So the good thing about object oriented is that once we create one blueprint, we can create multiple objects on screen. But we want processing to know that when we're talking about the X position, we're talking about the X position related to this specific object. So if we have two balls and they're both bouncing, we want processing to be able to distinguish between which ball we're actually talking about. This isn't strictly necessary at the moment since we're doing quite a basic example, but in other languages such as Python, this would be required. The next thing I'm going to do is add two very simple methods. I'm going to add an update method and I'm going to have a draw method. I'm actually going to call it display because I don't want to conflict with the built-in processing draw method. I'm going to leave the update one empty for now, but I'm just going to put something in the display just so I can just so we can have it on the screen and we can talk a little bit more about it as we're going along. So actually, now that I think about it, we haven't got a value in our diameter, but I'm actually going to define one up here. I could pass it into the constructor again, but I think for now we're just going to keep it so that they all have the same diameter. I'm actually going to make this a little bit bigger. Okay, so we've got our basic template now. It's very simple. At the moment it doesn't do anything. We just define a start X and a start Y, and then we can draw the ball on the canvas. But I think that's enough to get started with. So we're going to come in here and we're going to talk about how to actually get the ball from our template into an object that we can see and manipulate on the canvas. Okay, so I've added 3 lines of code in now, and I'm just going to go through each one of them and explain what it does. So up here we have our declaration. This is very similar syntax to what we'd use for defining a variable, and there's a reason for that. It's because it is exactly the same as defining a variable. So the thing is about our template over here is that we can think of the template as well as something that we can manipulate exactly like a variable. And there are other examples of this that you may have seen before and just not quite realized what exactly they were doing. A good example of this is the string built into processing. So this has a capital S to start out with, and although it's a keyword, as you can see highlighted, it is actually a class behind the scenes. And you can look at the source code for Java and see how they define the string. Another one unique to processing, which is a little bit more advanced, is the p vector, and this is simply holds an x and a y coordinate. When I write some more advanced programs, I may use that instead of an x and a y position, but we don't need to worry about that for now. So this statement up here simply declares that we're going to have our ball object, and the ball object is going to be of type this class. So the next thing that I added is this line down here. And again, when we define a variable, we would come up here and declare that we were going to make a variable, and then in our setup we actually set the variable. So we've done exactly the same thing here, but instead of just saying x equals 25, we need to say that the ball is a new ball, and this new here will call this constructor and set everything up for us. And you can kind of see that by the fact that we're calling the class and then we're passing in these parameters, which are the start x and the start y position of the ball. And what this does is it gets our template and tells processing that we definitely want to make this now, and it assigns the template as an object to this ball variable here. So if I print out ball, if I put print ball here, it will give us a very weird looking string. It will say object at memory location something, I think. And let's see, Here we go. So you can see here, it's actually said that we've got our bool object at this memory location. You don't need to worry about this for now. This is just something that processing's done for us. But the important part is that it knows that it's a bool object now, and we've got some data. So I've actually jumped ahead a little bit here by showing you what it's doing. But moving on to the final line of code, we have bool.display. And what this does, this dot notation that we've got here, is this will go into our bool and say, right, I'm looking at my bool object here, and I want to go into the bool object and I want to call this display method. And the reason we can't just do display, for example, is because we really want processing to know that we want to go straight to this bool and call this display. And I think this would become a little bit clearer if I made a second bool and explain it there. Oops. So I'll come here and I'll add on 100 to the width and the height to make sure they're in different positions, and then I'll do bool2.display. And I think this really makes it slightly clearer why we need this dot syntax here, because when we're calling a single one, you might think, well, we could just call this normally, but when we have two of them, you can see that actually we want to reference this object and ensure that we're doing the right thing for the object. So you can see here we've got our bool1, and then we've got our bool2 here, which is offset by 100 and 100. So I'll delete this code now, and we can get on doing some slightly more advanced things with our bool class. Okay, so I'm back in the bool class now, and before we left off with a very simple just display, but that's not particularly helpful, because what we really want is our bool to be able to move around, and we want it to be able to bounce off the walls. Because if you can remember all the way to the beginning of the episode, I said we were going to be working towards making a bit of a game out of this. So we want our bool to be able to have some functionality where it can bounce off of the walls, and then eventually we want to have a paddle that the player can move, and the bool should also be able to bounce off that too. So the first thing we're going to add is the functionality for our bool to actually move. And I think that it would be good to put this in the update function. So let's do that now. Great. So I've added in 2 lines of code that should enable us to move our bool. And these simply take our X position. Again, we've got the this dot to make sure that we're selecting the right bool. And then we're going to add on the speed. And currently this is 0. So I'll set this to 5, say. And it's going to do this for the X and the Y position. So currently this is going to just set the bool, or it's going to set the bool off at a diagonal. So actually, I think I might do an X speed and a Y speed. And I'll make these between -10 and 10. So this way the bool will move off in some random direction. Because I just thought before, if I have only one speed, it will always move off in this diagonal. So I'll ensure that we have our X speed and our Y speed. And these both need to be floats. Perfect. Okay, so we've filled in the update function, but as you can see when I run it, nothing actually changes here. And that's because we need to go back into our main one, and we need to call bool.update. And again, what this will do is it will go into our bool class, and it will call this update. And then it should move the X and Y position. And then we can go into our display. And you'll notice here that we don't pass anything in and we don't return anything. These are all global variables because these are all class attributes. And if I change something in one of these functions, it will change the value for the whole class. And that's why we need to have the this dots to ensure that it changes it specifically for this class. Okay, great. So now our ball should go off in a random direction each time. It will also have a random speed, which I'm not massively keen on. So you'll notice that these have between -10 and 10, and then we add them together and it will give us the direction, but also the magnitude. And depending on the ratio between these and also their actual sum, you'll get a different magnitude. So the ball will move off at a different speed each time. I could fix that with a vector, but I think it's a little bit more effort than it's worth. So I'll just leave it as it is for the moment, and I'll move on to the next part. So I'm going to add in a couple more methods now to our class. I'm going to add in a couple more Boolean ones, and these are going to check the X and they're going to check the Y. I'm actually going to call these check X bound and check Y bound. So what I want these to do is I want these to check the X and Y position of the ball and ensure that it's within the canvas. And if it is within the canvas, I want to return true, and if it's not within the canvas, I want to return false. And I'm going to do this for both the X and Y position, so I can properly invert the speed if it bounces off one of the edges. So I'll add this in now. Okay, so I've added in all of the logic for this now, and I think these should work perfectly well. So now I need to go in and add some logic into here to actually check if the ball is, or if these are returning properly, and then if they're returning true, we want to bounce off the side, so we want to invert the speeds. So I'll do that now. Great, so I've added in this functionality now. This is a very simple if statement, and then if these evaluate to true, then we're going to invert the velocity. So I'll run this now and see what happens. Okay, so this really wasn't the behavior that I was expecting, and let's see and try and figure out why that is. Okay, so I found out what the problem was. Some people with a bit more common sense than me will probably have noticed that in here before I had X position and Y position, but really what I needed was X speed and Y speed, because we don't want to invert the position, we want to invert the speed. So this should work perfect. So this works much nicer now, and you can see our ball is going along nicely and bouncing off all of the edges. And yeah, perfect. So the last thing I want to talk about now is the difference between public and private variables, or attributes I should say. So you'll notice here how everything that we've got looks very like all of the variables that we would define in our normal program and all of the functions that we would define in our normal program. And you'll also notice that we can call our ball.update and our ball.display with no problems. And this is the same with everything about our class. So I can print out here, I can print our ball.xspeed, And you can see down here, this looks a little bit ugly. I'll change this to a print line. But you'll see it can print our X speed and our Y speed with no problems. And this is because everything that we've defined is public. It's publicly accessible from our class, or it's publicly accessible from outside our class. So anyone can come in and they can mess with our bool. They can change the X speed, they can change the Y speed, however they please. And there is a way of stopping this. So you might think, why would you want to stop this? What's wrong with changing the things about our bool down here or outside of our class? So, well, there's nothing inherently wrong with that behavior. It does allow some errors and mistakes to creep into our program. So, for example, I am writing my bool class and I know everything there is to know about our bool. I created the functions and I made sure that I understand what all of this logic does. But say I left my program now and I left my computer open and someone came along and they were looking at our bool program here and they wanted to change something about the bool. Well, they could very easily come across and mess it all up, and they could change some things about our bool that we didn't really want changing. They could make the bool have a massive diameter, say, and this just isn't really practical at all. It messes up all of the code. You can see that our bool no longer nicely bounces off the edge. It just kind of comes in and has all sorts of weird behavior. So we don't really want this. Instead, we want to be able to protect our variables here from the prying eyes of the outside program. And we can do that by using the public and the private keywords. And I can come in here and put private in front of all of these variables or all of these attributes. And that will tell, and that will tell the person looking at our program that they're not really allowed to mess with these variables. So in many programming languages, such as the main Java and C and other languages, this would actually physically stop someone from using the variables. It would return an error and they wouldn't be allowed to. In processing, it doesn't seem like that's really supported. I can still mess with my bool position. So I can do something like this, say. So this made our bool a bit smaller, and we can make it really big again to make it obvious. So you can still come in and mess with things, but even though the official blocking of the attributes from being changed isn't supported, I think it's still nice just to tell people that, or to tell people the intent of what you're trying to do. And I'll come on to a couple of things that we can do to allow people to properly change our variables. We can do the same thing with our methods as well. So these updates, I want to make this public. So I want to make it clear that people are meant to call the update and people are meant to call display. And if I was writing a proper library now, I would perhaps add some comments in. So I would come in and say something like this. So anyone looking at this code in the future can clearly see what all of this is meant to do, and they can clearly see that they're allowed to access these, and they're meant to be. And then I'll come down here and I'll say these are private, because these aren't really meant to be called by the outside world. They're only meant to be called in here. Yeah, so we'll do something like this. So now anyone who comes and sees my program will be able to see that they don't need to access any of the attributes. They're not allowed to change these, and they're not allowed to check the X and Y bound, but they're more than welcome to come and update the bool. They're more than welcome to display the bool in their main program. And this really helps, I think, make the code a lot clearer to read. And helps people, especially if you're writing code for other people, helps people to know what they're meant to be doing. So we've protected our diameter up here and we've made our radius private. But what can we do? Say someone wants to come in and they do want to make a circle, but they want to make more than one ball, and they want one of them to be slightly bigger to distinguish between them. But they're not allowed to. They're not allowed to change our diameter, and they're not allowed to mess with our radius. So what can we do in this case? How can we make it so that they're allowed to do this without making it too insane? They're not allowed to make it too big. Well, the official method of doing this is called getters and setters, and these are simply methods of the class that allow users to properly set variables within some restrictions that we want to place on them. So I'm going to create a new method down here and call it change diameter, and it's a void method. It doesn't need to return anything because all it does is change our diameter variable, and we're going to take in an int of new diameter, and then what we're going to do is we're going to set the diameter equal to new diameter. So you can look at this now and you might think, well, this is pointless. Why don't you just let them change the variable as it is? Then we can avoid all of this fuss, because now they're still able to set the ball to a crazy limit. There's nothing restricting them, and it doesn't change our radius either. So the radius of the ball is unaffected, which is why our check xbound and our check ybound functions broke earlier. So what can we do about this? Well, the radius one is very easy to fix. We just do diameter divided by 2 again. Oops, and we want to put this dot. I need to remember that. Okay, so we can set this to the diameter divided by 2. So this should allow us to change our radius and not break the oops. What did I call it? Change diameter. So this should allow us to change our radius, but not break. Well, it did break because the ball is still massively large and it spawned off the screen. But now you can see that the ball is still bouncing properly, even though it's got a different diameter to the base diameter. And that didn't happen before when we just changed the variable. So we've already made some improvement to our program, but we want to improve it even further. We want to make sure that if I make this bigger than the canvas size, our ball just looks super weird. Well, you can't even see that now, but if I make it the same size as the canvas, as you saw before, the ball has some really weird behavior. It's clipping off the screen. It's just not pleasant at all. This is not how we want our ball to be. So we want to not allow this. So what we can do is we can say, we'll define a private variable up here, and I'll call it max diameter, and I'll make this equal to 500. I think that's a reasonable thing. And then what we can say is if okay, so now I've added in a couple of lines of code. Now we've said that if the new diameter is less than the max diameter, oops, I need to add that in, then we'll set the diameter and set the radius. Otherwise we're going to print the diameter is too large. So as we can see down here, we've come in with 1000 and it keeps printing that the diameter is too large, and it doesn't allow us to change the diameter. But if we come in here and we say this is 499, which is just under, then it does allow us to set it perfectly well. So now we can see the advantages of having our setter to allow us to set the variable to something sensible. Oops, it appears as though I've broken some code. I'll have to go over and look at what I've broken. But the fact still remains that we've set our variable to a sensible size that hopefully shouldn't have broken anything. and yeah, we haven't allowed them to set it to something crazy. Okay, so I just ran the program again, and it looks as though that before was a bit of a glitch. I'm not entirely sure what caused that. If anyone can spot what caused that in the code, then please please leave a comment or something. But for now, I think I'm going to leave the video there. I think this is a good stopping point. We've got our ball that's bouncing around. We can update, display, and change the diameter of the ball without breaking anything. And yeah, so I'll make a next episode, I think, a second episode where I'll add in the paddle here, and I'll add in some code, a couple of new classes to make some blocks up here, some breakable blocks, and a paddle down here that can be controlled by the user. So thank you very much for watching. I hope this was helpful. I know it's not quite the same as what I've been doing before, but I've had some concerns about just sharing portfolio code directly. So I thought this might be a nice way to hopefully share some of the skills without directly impacting or without directly sharing the portfolio code. So please leave a comment if you liked it. I'll make the second episode if I get some positive feedback. And yeah, thank you all for watching.